Looks like shutting off my camera before class starts actually really did help the load time a lot. Okay. Nope, start video. Okay, there we go. So today we're going to finish up 1.1. You should have, go to joinpd.com. And then the code should appear on the shared screen. Okay. All right. So I'm going to go ahead and put that in chat so I can close out of this. So go to joinpd.com and that's CLZLZQ. CLZLZQ. Okay. And then you should be at a screen that looks like this. Okay. And this is similar to the problem that we did for bell work, or for like the last example and the last guided practice for writing linear equations. You have here a word problem. I need you to write a linear equation. In order to write a linear equation, there are two steps. You need to find the slope and the y-intercept. So using like the Celsius as the x value of a coordinate and Fahrenheit as the y value of a coordinate, you should be able to make two ordered pairs, which will give you one of the points you need. And then you should be able to tell me the slope between those 2 points using your slope formula. I'll give you, it says 3 minutes. We'll see. We might need more time on that. I always forget to close my door, so I'm going to close my door. This is a fun one because it's got real world applications. Oh, and then after you write the equation, make sure you go back and use your equation to tell me what the temperature and Celsius is when Fahrenheit is 20, or wait, reverse that. Temperature in Fahrenheit when you have 20 degrees Celsius. Well, okay, it looks like we have 6 out of 17 responses, so I'm going to guess we need more time. So I'm going to just start that 3-minute timer over. No, not stop barking. Start over. There we go. All right, and then when you get done, you should be able to type your answer in the old text box. Again, if you're not in the joinpd.com to submit your answer, okay, that is, come on. That is, oh, girl, That attendance did not work at all. Okay, let's try this a different way. Okay, worked that time. Let's see how y'all are doing on this. Okay, yeah, we're getting more not show responses. This is what I want. Let's see how we're doing. Okay, it's good. Oop. Okay. Okay, so far that's good. That's good, Mariah. That's good, Faith. Ana. Okay. All right, that works. Okay, actually, all of you have done pretty good. There's a few where I think you may have just put the decimal in the wrong spot, and there's a few of you who put the y coordinate in the wrong spot when you plug this in. Okay, so I'll go through it just really quickly, and then you tell me if I need to go through it slower. Okay, so the first part, setup, is I think where I saw the most mistakes, and in fact, maybe where I saw the only mistakes was in the setup of this problem. You got to be very careful how you write these points. This Celsius is the X. Fahrenheit is the Y. So this is the point 032, not 32, 0. And then over here, this would be the point 100, and then zoom window's getting in the way, 212. Oh, geez. I feel like I need dual monitors. That's what I need. That's not going to happen. Maybe I can bring another. Okay, that's the second point. So this is your first X, first Y, second X, second Y. Most of you got the slope correctly. You just do the difference in the Y's, 212 minus 32, over the difference in the X's, 100 minus 0. That reduces to 9/5 or 1.8. I think some of you, when you were typing, you put 18 instead of 1.8. But I knew what you meant. All right, and then when you're substituting back in, it's y minus 32 equals 9/5 or 1.8, x minus 0, right? Remember, this is your slope, and this is your x1, y1. Some people switch those, and they put y minus 0 equals 9/5, x minus 32. Be careful of that. Look back at your point and make sure x goes with the x, y goes with the y. And then when we plug in 20 for Celsius, which again is x, right, you should get, move this zoom windows, always in the way. Oh. Y minus 32 is equal to 9/5 times 20, which is what, 36? Is that right? Plus 32 then is 68. Yay. Good job, everybody. Any questions on that? Or any part of that you want me to talk about again? Perhaps slower. No? Are you sure? That's what I'm here for. Also, look at these. Isn't that pretty? It's an orchid. All right. All right, let's move on then. You all did pretty good on that. I was pretty impressed, especially it's hard to remember, and this is probably gonna be a struggle for this class. You have to go from Thursday to a Monday, remembering the content, and that's gonna be a challenge every week. What I could do is I don't know, what'll help you eventually is hopefully procrastination. That'll help you. So you do Thursday, okay? I give you homework, you say forget about it. Ain't doing that. And then Sunday night, go and do it. Or I don't know, do half of it. Don't leave yourself a ton of homework Sunday night. That's never great. But like leave, I don't know, 5 problems. You do Sunday night, get yourself warm again so that when you wake up Monday morning, have to do all this stuff again. All right, here's what we're finishing out today is sketching lines, graphing, easy peasy lemon squeezy. And then parallel and perpendicular lines and using that to identify slope, which parallel, easy peasy, lemon squeezy. Perpendicular is always going to be the one where you're going to be like, oh, I remember I'm supposed to do 2 things. What are those 2 things? That's one that people usually mess up on the test for this chapter, is that one, just because they know they're supposed to do something, but they forget what they're supposed to do. But that's not going to be you. Because you're going to take sweet notes today. Your notes are going to be so sweet. By the end of this class, you're going to look at your notes and be like, oh my gosh, I have to frame every one of these pages and put it on my refrigerator. Before we actually get into it, hopefully you saw this in Classroom. I put an announcement that told you how to get into WebAssign. That is something that you'll need to do by Wednesday when we start 1.2. 1.2's homework will be through WebAssign. So you won't have to like do it on, I mean, you could do it on paper and pencil. You could use a Google Docs to do it, but you don't have to. You can just do it in WebAssign. And it's really cool. It's got a whole bunch of really cool resources. Like it'll take you, it's got, oh, it's, maybe I'll go over it. I'll go over it Wednesday. It's really, oh, Wednesday's gonna be a short class. I don't know, we'll go over it Wednesday or we'll go over it Thursday, Friday, but it's got really cool features that'll make your homework a lot easier to do. It has so many tools. I know a lot of you said that what you look for most in a teacher is for them to be helpful. That website is helpful. It has so many resources. There's like, it's almost too helpful to the point where if you're, it kind of removes any excuse that you could have made. Like sometimes you could say, oh, I didn't understand this part of the lecture. I didn't understand how to do like this side of problem. So I did the rest, but I didn't do that one. That's not really an option in website because it will send you to the place in the textbook that has the notes over that type of problem. So you could read it and review it. It has a video lecture over that section of the resource or section of the book. So you could listen to somebody else explain that text if Mr. Lakes didn't make any sense to you. I mean, I'll have my web video, this lecture will be posted in the Google Classroom, so you could just watch this again. But then it will also, it does even more than that. It'll give you another problem, exactly like the one that you just did with maybe like different numbers and walk you step by step how to do that one. And so you could just apply that to the one you're doing. I think it has one more really cool feature I'm forgetting about right now. That'll help you too, but it's really good. Big fan. Okay. All right, I'm done talking about that. We're getting to the notes. All right, subpoint D in your notes. Next subpoint, you should add AB. This ABC is a D. Or if you're doing whatever different outline notes, that's fine. If you want to sketch the graph of a line, you need to plot a point, or that point could be the y-intercept. And then use the slope to find other points on the line. So what I mean by that is once you have plotted your point, right? So here's my point, x sub 1, y sub 1. And I need to find another point, right? You need 2 points to draw a line. What I would do is I'd use my slope to find other points. So I would, go up the rise and the change in y, and then go over the run, the change in x, to get my second point. Again, that's using your slope. And then you draw your line. Woo! And that's your line. This is a birthday cake. It's your flowers there. And it's got sprinkles on the birthday cake. Okay. 3-tiered. Pretty good. Have you, okay, you have probably, I just tried this on Friday. I don't know what it's called. It's like on 29th in Wanamaker. Or 21st in Wanamaker? 29th in Wanamaker? 21st in Wanamaker. Southwest corner. I think it's called Nothing Bunt Cakes. That place has some good cakes. You can get like a single portion, which you could probably split that portion between 2 sittings for like $4.50. It's good. I got the red velvet. I liked it a lot. Wife and Lincoln got the chocolate chip. That was good too. But I think all 3 of us got the same cake, because isn't the difference between red velvet and chocolate cake just food dye? Isn't red velvet just chocolate cake with red food coloring? If anyone disagrees, you can unmute and tell me otherwise, but I think I'm right. My wife says I'm wrong, She says, they're different. They taste different. You can tell they taste different. I don't think they do. It's kind of like how M&Ms, they're all the same. Yeah, no, they're different colors, right? But they all taste the same. Like Skittles, they're all different colors, but they all taste the same. Okay, are we done with this?
All Skittles taste the same.
All Skittles taste the same. Yes, they do. All right, we're going to clear this, and we're going to move on. Clearing this. All right, let's do it. Let's graph this. This is going to be easy peasy lemon squeezy. Pay close attention, because if you miss it, then you'll be like, oh, I already knew how to do this anyway. This is in standard form, which, as everyone remembers from the lecture last week, is the worst form. Okay, this is bad. So we're going to fix it. We're going to get into, let's say, slope-intercept form. So I'm going to subtract x from both sides. Get y equals negative x plus 2. That tells me that I have a slope and a y-intercept of -1 and 2. I then plot the y-intercept, plot. And then use the slope. This tells me I have a rise of -1 and a run of, notice that there isn't like a -1 over something, so the run is always going to be 1 then, right? And they don't put the -1 over 1 because, of course, anything divided by 1 is just itself. No need to write that extra detail. We all just know that that means the run is 1. So that means I go down 1 over 1. Or I could go up 1, left 1. Look at this. Look at the crazy things that's happening in this class right now. And you can go down 1 over 1. And I can just do this to my heart's content. Just keep doing it. Down 1 over 1. How do I find another point? Well, I go down 1 over 1. What if I wanted to find another point? Well, I'll go down 1 over 1. What if I wanted to find another point in like a different area? Well, I could go up 1, left 1. What if I wanted to find 2 points? I'll go up 1, left 1, and then up 1, left 1 again. You can't stop me. I could plot points forever, and nobody could stop you. You just plot points on this line for the rest of your life. And if anyone tries to say, hey, stop it, you have another class, you'd be like, I'm doing pre-calculus. What do you expect of me? Okay? And they'll be like, you're right. Keep plotting lines. You'll be 30 years old still plotting that line. And they'll be like, isn't that enough? And you'll be like, no. I'm doing pre-calculus. And they'll be like, that's legitimate. That's a fair thing to do. Okay. Sorry to bother you. Let me get back to it. Questions, comments, concerns? I'm going to clear the drawing and move on unless somebody says, no, Mr. Lake, you already had a graph drawn, but we didn't, so it took us more time. Y'all are too good. Too good. Okay. All right. Now you get to do a drawing slide. Oh, you haven't been able to do a drawing slide in Pear Deck yet, have you? You can draw both of these graphs on the actual graph on your screen using your finger or your stylus. Be ready to share your answer with, I don't know if we'll do breakout rooms. I don't know if we'll do breakout rooms for this. I'll look at the responses. If your responses are all, stop it. If your responses are all great, we will skip the breakout room. But if everyone draws graphs that suck, we will do the breakout room. Okay? That's how we'll decide it. And now my 3-minute timer doesn't want to look. I'm going to know 8:22. 8:22 is when I'll check your graphs for how bad they are. Dylan, the join PD code is in the top right. So go to joinpd.com, CLZLZQ is the code. Oh, now it'll work. Okay, I'm gonna move this to 2 minutes. Another way I suppose you could plot the first one is by finding the x and y intercepts. That's something. Think about that. You know, I might also be thinking, Mr. Lake, in your slide that's there, you told me to plot the intercept and then use the slope. What if what if there is no x term? Well, then I'm going to ask you, what's the slope then? What type of line is that? Uh-huh. Yeah, turn the question back onto you. How do you graph number 2? What kind of line is that? Is it a diagonal line? Is it not a diagonal line? Are my helpful comments during your work time distracting? Are they helpful? That's not what I wanted to do. I don't want to show them yet. I want to look at them. How do I look at them? Okay. Stop it, dog. Okay, let me look at these. I'm looking at your work now. Okay, that person only graphed one of the lines. Uh-oh. Should be 2 lines. Okay, never mind. They just did it while I was talking about it. That person did great. Okay. That one's okay. It looks like for the most part, everyone is doing it just fine. Yep. Only issue I've seen is it looks like one person accidentally switched the slope from a positive to a negative. Once you solve this for y, it should have a positive slope, not a negative. So check your negatives, but you have it graphed from top left to bottom right. It should be bottom left to top right. And then one person did this. Oh, actually 2 people switched the slope. And then one person flipped the y-intercept. So one person, so it looks like 16 out of 19 got this perfect. And then the 3 people got it good. They just missed half of one of the questions. So I'm going to say no breakout room. So, okay, this one, you should end up with it looking like this. Like that, bottom left, top right, okay? Y-intercept -2. And then this one, which I can do in a different color, because look at that, boom. Goes like that. That's a horizontal line. And everyone got that. That actually is impressive. Not a single person put a vertical line there. That is good. And it should make sense, right? If you think like this is in y equals mx plus b form, right? It's just the m is 0 and b is 2. And if m is 0, that means there's no rise. So it's a flat horizontal line. That I'm actually a little surprised on. You have impressed me. And for that, you earn another look at the flowers. Go. Good job. I think that's the first time in my years of teaching that has happened. I almost always have to stop here and say, hey, what's the difference between a horizontal and vertical? Here's easy ways to remember if it's horizontal. Here's easy ways to remember if it's vertical. You're just firing on all cylinders. All right. Before we move on to parallel and perpendicular lines, then, I'm going to give you some independent work time. That's very generous. I know. So you have the homework assignment, right? It's the 1.1 guided notes and assignment. We just went through this cycle, which again, this part you don't have to do, the guided notes part. If it is useful, you can do it, right? You can draw the graphs that we just did on here as like your notes. Here's where the homework starts at the bottom of page 2. You should now be able to go and do all the way through number 8. And maybe more. You probably could do some of these later ones too if you get done or you get bored. Like 11, 12. Actually, I think you could do all of these 11 through 15 because those are more like just word problems. The only ones I haven't lectured on really are 9 and 10. But to be honest, based on how I've seen you all do in class so far, you could probably do 9 and 10 too. So it's 8:26. We will start the last bit of notes for 1.1 at 8:35. I'll write that on your screen on the annotate part here, 8:35. So if you need to use the restroom, get a drink, go pet your dog or cat, that's fine. And then we'll start back in 8:35. This is also a great time if you have a question for me and you want to unmute yourself or send it to me in chat, I will do that. I can help you out. I think I forgot to share sound. So you can, you all need bad music right now. It's not bad. Why did I say that? It's not bad music. It's good music. There we go. But if you don't like the music, of course, you could mute it right here. Or turn the volume down, right? Say 35. What am I doing? I'm doing this. Okay, okay, and then we go back to this slide here. Clear the drawing. All right. Last section of notes for 1.1 to finish this out. And again, this is probably the point in class where you want to make sure you get this down. You don't want to be one of those people on the test or quiz that get to, how do I write perpendicular lines from a given line and be like, I know there's two things I'm supposed to do, but I don't remember what they are. This slide will tell you what they are. But first, let's talk about parallel lines. Parallel lines are two lines that never intersect. They continue forever in both directions, never growing more apart or closer together from each other. And we say that their slopes are equal. That is, if we have two lines, nope, let's draw blue. If we have two lines, line 1 and line 2, who have slopes M1 and M2, then we could say L1 is parallel to line 2 if and only if the slope of line 1 is equal to the slope of line 2. That's okay. That's the parallel marks. This means parallel. Oh gosh, I need a better stylus. One with a fine tip. Why, does anyone want to tell me why the non-vertical part is in there? Does anyone have an idea of why the non-vertical part is in there? Chat? Vertical lines don't have slope. That's right. Remember, vertical lines, their slopes are undefined. So they can't be equal. Sneaky. Very good. So we would say if two lines have undefined slopes, then they are parallel as well. Isn't that wild? That's fun. Okay, that's why. Okay, good. That was worth it. That was worth it. All right, two non-vertical lines are perpendicular if and only if their slopes are negative reciprocals of each other. Look at all those $5 words. All right, so again, if we assume that we have line 1 with slope 1 and line 2 with slope 2, then we will say that line 1 is perpendicular to line 2. Perpendicular. If and only if they're negative reciprocals of each other. So that means a number of things, but most importantly, that means if the slope 1 is equal to -1 over M2, slope 2. Another way you could write that is that the two slopes multiplied together would equal -1. And again, that would be something like if slope 1 was 2/3, then slope 2 would be -3/2. So the two things you have to do to get a perpendicular slope is flip it and change the sign. You flip it and you change the sign. You take the fraction and you flip it and then you change the sign. You take your fraction, you flip it, and then you change the sign. And then sometimes people will come up to you off the side of the street while you're walking down 6 feet apart and say, hey, how do I know if two lines are perpendicular? And you say, well, buddy, all you got to do is look at that slope and look at the other slope and then see, can you flip it and change the sign? And they're like, I knew that. Sorry for bothering you. And you'd be like, yeah, you're right. You're sorry. Keep walking. I got places to be. Don't need to tell you about perpendicular lines. Because all you got to do is flip it and change the sign. I've been teaching precalculus for quite a while now, and all you got to do is flip it and change the sign. People will be like, well, what did you teach last year? Well, I taught them you got to flip it and change the sign. And they'll say, well, what if you change the sign and then flip it? And I'll go, okay, so you're going to be one of those problem kids, huh? A lot of behavior referrals for you. You think you can change the sign and then flip it? How many times did I say flip it and change the sign? And you want to come in and you want to change the sign and then flip it? Well, you think you're all that? You think you want to run the classroom? Okay, fine, you teach the class. I mean, they're right. You could change the sign and then flip it, but it's not as fun as saying flip it and then change the sign. You understand. You all understand that. I don't need to explain that. I'm not the crazy one here, okay? I'm not the crazy one here. I don't need. Flip it, change the sign. Okay, let's do an example because I'm losing it over here. I need to be grounded by examples. So here, given the line 2x minus 3y equals 5, that's a line. Find equations of a line through the point split poorly by the formatting of this slide to -1 that are parallel or perpendicular to the given line. So I need to find all the equations that are parallel to this line. I need to find all the equations that are perpendicular to it. So that is not a well-written prompt. What am I talking? There's an infinite number. This was so, no, there's not. There's only 2 because it's through the point. Never mind, Mr. Lake, I take back my criticism. Good job. This is a well-written prompt. Okay, so in order to write the equation of a line, you need 2 things. What are the 2 things you need to write the equation of a line? Slope and a point. All right, so if I need to write the equation of a line, I need slope and a point. Hey, look at this. Are you all looking? I know you are because it's a shared screen. You see my screen. That's the point. So I just need the slope. Okay, to write the slope, let's do the parallel one first. I know if 2 lines are parallel, they have the same sweater. Nope, they have the same slope. So to find the slope, I need to find the slope of this original line. Again, this is written in bad form, our standard form. But we can fix it and make it into slope-intercept form. So to do that, I'm going to take this and make it into slope-intercept form instead of the bad form. Instead of the bad form, this is going to be slope-intercept form. It's going to look so good. All right, subtract 2x from both sides. That's -3y equals -2x plus 5, don't you know? Divide by -3. I write too big. I didn't give myself enough room, so I'm going to go back up here. That is y equals positive 2/3. See the 2 negatives, right? They make a positive. Just like 2 wrongs make a right. 2 negatives make a positive, just like 2 wrongs make a right. Okay, so this line, my original slope, has a line of 2/3. So then, if I'm saying they are parallel, then I know my new equation also has a slope of 5/3. Right? Not 5/3. 2/3. So then I use my point slope form. I now have slope. I now have a point. I can write in point slope form my equation. So my equation would be y minus -1. I'm going to go ahead and turn that to a positive. If that offends you, you can write a letter of complaint to the Kansas Board of Education and let them know Mr. Lake changed 2 negatives into a positive and just did it without even writing it as like a separate step. And that just offends me at a fundamental level. And it won't be the first time I've gotten one of those letters. You don't even have to put my name on it. They'll be like, that's that guy teaching over at Topeka West who just skips the step where you write minus a negative and just makes it a positive the first time he writes it down. I mean, what? That guy. Always trying to rein him in, but he's just too chaotic. Okay, does everyone see how I got that? This came from that, right? Minus a negative was a positive. So right there. I'm circling stuff that you probably don't need me to circle. This came from that, right there. That color's not going to show. This came from that, and it went right there. Okay. Look at this. Look at this erasing function here. Isn't that great? I just click the little lines, and it just erases the color that I wanted it to. I just wanted to show that off. All right, let's do perpendicular. Okay, to do perpendicular, I take the slope, and I'm supposed to do 2 things. Flip it and change the sign. So then I'll call this slope 3, just so we don't mess up our notation. So in a 2/3, it becomes 3/2, and then instead of positive, it becomes a negative. And then really that's the only thing that changes. I'm still using this point over here, right? That's the point that it has to go through. This is my slope. I do y plus 1 equals -3/2 x minus 2. And then you might say, Mr. Lake, do we need to convert those to slope-intercept form? And the answer is no. And then you might say, Mr. Lake, is it okay if I turn it into slope-intercept form? And I'll go, sure, it is okay if you do that. But if this is a correct answer, and then you mess up turning it into slope-intercept form and make it an incorrect answer, I will take the +1 point I was going to give you, and I will give it to somebody else in class. And you don't get any more if you mess up. Fair? Okay. I'm going to erase this and move on to our guided practice unless somebody says, no, Mr. Lake, you drew with so many colors. It was hard to follow along and I wasn't quite paying attention, and then my cat ate my dog and I had to go fix that while you were doing this, so I didn't have enough time to write everything down. Okay. All right, last guided practice. So I give you the line 5x minus 3y equals 8. Oh no, that is not in a form that makes it immediately apparent what its slope is. Ugh. And the point. You need to write an equation that goes through this point that is parallel to this line. And then you need to write an equation that goes through this point and then perpendicular to this line. One audible. Are you ready? Are you ready for some chaos? For Pear Deck, do not submit your answer to number 1. You all have impressed me already. I think you could do that. Submit your answer for number 2. I'll give you 3 minutes. That's more than enough, I'm sure. If you get stuck while you're doing this, or just need a little reminder, unmute yourself and ask me or send something to me. Yeah. And I'll help. Doing on these responses, not quite everyone's in yet. Let's see how we're doing. Okay, that's fine. That's good. That's correct. That person switched up their negatives. That's correct. Correct. Switched up a negative. Correct. 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 Switched up a negative. Oh, one person might still be working. Okay, then we got some people still working. Okay. You want to do breakout room? No. Shrug, maybe. No, Cody says. Emma's like, Okay. Yeah, I think you're right. I think I like to do breakout rooms because you talking about it will help get it into your long-term memory. But I mean, out of all the ones I've seen, you all have gotten it right. So I think what we're at is like, this stuff is still pretty easy. I mean, maybe you need me to go over it a little bit, or as a refresher, but other than that, I'm good. Okay, so let's just talk about the slope really quick then, because it seems like just to make sure we're all on the same page on why the slope for number 2 here should be negative and not positive. All right, if you solve this one for y, you should get negative 3y is equal to negative 5x plus 8. Divide by negative 3, you get y is equal to 5/3 x plus 8. So this is your original slope. Okay, for your equation for number 1, that should be your slope, right? Your new slope should be 5/3 as well, right? Because they have the same slope. For this one, it should be then negative 3/5. Flip it and change the sign. Flip it and change the sign. Okay? So, but everyone is actually doing a great job of writing things in point slope form. Like the form that you're writing in is great. I'm really impressed by that. I think then, I mean, let me double check. But yeah, I think that's it. That's done. That's done already. So I'm gonna go ahead and well, okay. Let me write it in point slope form just in case somebody is here, and this will also be for those who watch it later. Right? I may not have gotten it. Okay, that's in point slope. Y minus 1 equals negative 3/5 x plus 4. Okay, again, the minus and negative makes it a positive. It's always the opposite of those signs that they give you for their point. Okay, so then what I would like to do for the rest of class, here is your exit ticket. Fill out the most important thing that you learned from today's lesson. It actually doesn't say that you learned. Just write the most important thing from today's lesson. Okay, that's your exit ticket. For the rest of these 30 minutes then, you have 3 tasks to complete. Some of these tasks may have already been completed. You need to enroll in WebAssign. You need to download your calculator. And you need to complete the homework. Okay? So I'm going to write that, annotate that on the slide. The 3 things that you need to do are, again, enroll in WebAssign. Download the calculator. God, maybe I should use text. You know what? Mr. Lake is going to evolve as a person right now. You ready? 1, look at this. Whoa, whoa, whoa. Look at that. Mr. Lake pulling out all the stops right here. This is how you know you're paying the exact right amount for this class, for high-tech solutions like this. Okay, that's the 3 things that you need to do. Okay, I will be here, of course, for the whole time. I'll be here till 9:30. Oh, yeah, good question. If you do have your own graphing calculator, like if you have your own TI-84, then you don't need to download the app onto your Chromebook. So then, yeah, that step's done. Or, okay, or to be more, yeah, this is fine. Or to be more honest, okay, we'll see how this works. Sometimes okay, that's okay. So if you have an Android, okay, you can go to this app called Wabbit Emu and download that as your calculator, and it'll just put it on your phone, a little emulator of it. But that's Android only. It's okay, it's not Android only. It's free on Android only. Wabademu, I believe, is also an app in the iPhone store, whatever that's called. But I think you have to pay for it. It's not expensive. I think it's like dollars, but you do have to pay. I think there's a free one, but like it changes every year. Like I'll be like, ask my iPhone people, be like, can you find one on your iPhone that's free, a graphing calculator emulator? And they go, oh yeah, I found this one. It was all right. But I'll type that in chat. Wabbit Emu. Wabbit Emu. That is for Android. It's free. And when you're doing it, it'll ask you what TI-84 you want to emulate. I believe I typed it as a private message because I'm a dingus. It'll ask you what one you want to do, and you want to do the TI-84 Plus C Silver Edition. When it asks you which emulator or software that you want to download for it. That's the newest one. That's the most advanced one that you are still allowed to use on the ACT. Okay, so when you're doing the homework, quick reminder there, when you're doing these problems, you can just do it on a separate sheet of paper, take a picture of it when you're done and email it to me, or you can do it in the doc, type, inserting images, inserting equations, all that fun stuff you can do on Google Docs. Or you can use Cami and open the PDF version of the assignment, and then you can use your touch screen to just draw and write in your answers in each box, and then save it, go to Google Classroom and turn it in. All right, I'm gonna be here till 9:30. If you complete those 3 tasks before the end of class, or while you're working on this during class, if you wanna turn off your camera and mute yourself, that's fine. I would recommend you stay in the Zoom chat until the end. That way, if you do have a question that comes up, you can just ask it to me immediately. I don't know, I think that covers everything. Is there any questions that you all have for me? Okay, yeah, I can go over 13. Yep. I can do that. Let me fix attendance really quick. And then we'll do that. Tomorrow, not tomorrow, Wednesday, next time we meet, we'll do 1.2, which you should now in your WebAssign, and we'll go over WebAssign, because WebAssign not only is the homework, but it also has your ebook. It has your textbook for this class in there too. So 1.2 will be on Wednesday, and then Thursday we'll do 1.3 and 1.4. We'll go a little bit faster than we have for these last 2 days, for these last 2 block days. I'm going a little slow. That way, if someone joins or transfers into the class, they're not completely lost. We're going to pick up the pace a little bit starting Wednesday, so be ready for that. Okay, I think I did that correctly. All right, number 13. Okay, I'm going to clear this annotation. Can I move this annotation? Can I move it? Text, can I do that? Is that allowed? I can't. Why would it let me move it? What kind of world do we live in that it's just like, okay, whatever. Type it back in. Okay. Okay. Let's see. In 2000, the University of Massachusetts Amherst had an enrollment of 23,570. By 2017, the enrollment had increased to 30,340. What is the average annual change in enrollment? That is a great question. I like this question. Okay, so here's the key. What does it mean by average annual change? So You might draw a little graph of this to help understand that. Let's say this is 2000 and this is 2017. Let's say this is, let's count by tens, 10, 20, 30, 10K, 20K, 30K people. Okay, so in 2000, it's at 23,570, which is right about there. In 2017, it's at 30, so right about there. What I want to know is what's the average annual change in enrollment. So the idea is for every year we go over, how much did the enrollment go up? For every year we go over, how much did it go up? Every year we go over, how much did it go up? Every year we go over, how much did it go up? Is that a familiar concept to you? How much did we go over and how much did we go up? Right? All it's asking is for, and then the average of all those things should end up being the same as the total amount we went over compared to the total amount we went up, or the run compared to the rise. So this question is a thinly or not thinly, a secretly disguised what's the slope question. This question is, what is the slope? So then use your points. Make sure X is your time, okay? And then Y is your people. So I would have my points as 0, 23,570, and 17, 30,340. It's my X1, Y1, X sub 2, Y sub 2. Okay, and then find the slope between those 2 points. That is an AP style question where they will ask you what is really mathematically, like once you know what it's figured out what it's asking for mathematically, not too bad to do, but it does mess you up. Good question. While you're doing these problems, you should show as much work as you can. So for example, for this problem, what I would consider sufficient work for number 13 is you tell me, okay, here, I'll draw it in a different color. I'm gonna draw it in a different color. If you turn in an assignment that looked like this, M equals, or instead of M, you put average change, average annual change, and you, gosh, average annual change, M or M, whatever. Okay, whatever you choose to start this, I don't care. M, average annual change, is equal to 3, 0, 3, 4, minus 2, 3, 5, 7, 0, over 17 minus 0 equals blah. That's not. This would be enough to get full credit for that answer. Yeah, that would be enough. So yeah, when you're doing slope for any of the problems, just show, all I need to see is the equation you used with the numbers plugged in correctly equals answer. Well, that's enough work. And that's what they'll want on the AP test too. Though they're probably a little bit more stricter. They are more strict than what I just said. When the problems start to get more complicated, you do need to be precise. Like they would need you to put M equals equation plugged in equals answer. This would be fine. It would not hurt if you wrote the M equals equation, then with the numbers plugged in, then the answer when you're doing the AP test. Yeah, would not hurt isn't necessary, but it would not hurt. All right, any more questions? Okay, let's check the old chat. Oh, that is a great question. I love that question. That is, okay. How many decimal points should you round to? I will, on all these problems, I probably, unless I mean something else, I will just not write how many you should do most of the time, because this is one thing I love with the AP Calc test. They just said everything, I don't care what problem you're doing, everything is to 3 decimal places. Every problem, that's how much we're going to forever. Okay, so like if this comes out to a decimal, you would say bleep, blop, dot, bleep, bleep, bleep. The, what was that, the 10th, 100th, 1000th place. Everything is to the 1000th place. So everything in this class will be to the 1000th place, unless I say otherwise. Always 3 decimal places. If you get in that habit now, you will not, okay, and it's really, I had this happen to people last year on the AP Calc test where they rounded to 2 instead of 3 decimal points, and then they lost points. That's rough. It's rough to do all the problem right and then not get the answer correct or get the point for the answer because you went to the wrong number of decimal places, but they will do that to you. So if you get in that habit now, then hopefully next year you'll just already be in that habit. Everything is 3 decimal places. Good question. But that's also a reason why I say, you know, again, once you have your, like, okay, actually, to be more honest on the AP test, which I know some of you are saying, Mr. Like, I don't really plan on going to AP Calc because this is the last math class I'm going to take. But humor me. I'm teaching this class so that if you wanted to go to AP Calc, you could be successful. On the AP test, they don't even need this. They don't even care what the actual answer is. Once you have just numbers, you're done. This problem is done. M is 30,340 minus 23,570 over 17 minus 0. I don't even care what that calculates out to be. You're done. Good questions. Mhm. All right, well, while we work for these next 15 minutes, I'm going to go ahead and mute myself. That way you don't have to listen to random noises that I might make while I grade stuff. But if you have a question, I'm still here. Unmute yourself and ask or put it in the chat. Another good question. When you're submitting, I don't need your notes. If you want to take a picture and attach them all together, that's fine. Uh, but all I need for the grading portion for Wednesday is the homework. So you just take a picture of those pages and send me those. If you include the notes, that's great too, but not necessary. All right, let's look at number 12. All right, clear all this. Yep. Okay, suppose a company has a product value, product valued at 2,540 in 2018, and its value has been increasing at a rate of 125 per year. Write a linear equation. That's key. Write a linear equation that gives the dollar value V of the product in terms of the year T. All right, so in order to write a linear equation, you need two things: slope and a point. And remember, this is kind of like we were talking about in number 13, that your slope is the same thing as your rate. Okay? So your slope is actually given to you in this problem, in the first line. Okay? And then the second thing you need is a point, which in our terms, point is going to be written as T sub 1, V sub 1. Instead of X sub 1, Y sub 1, we're going to use T's and V's for this problem because we get crazy after problem number 10. Up is down, left is right, dogs, cats living together. And this is actually also given to you in the problem. You need to tell me what is a time that they give you and what is an amount or value that they give you. And then once you have both of those things, which you can get from line 1, you're going to write your equation by doing V minus V sub 1 equals M times T minus T sub 1. And again, this goes there, this goes there, and this goes there. That goes there. Okay, V and T stay V and T. And note, again, let T equal 0 represent 2,000. So this number is not going to be 2018. Okay? Does that make sense for number 12, or do you need more?
I get it.
Okay, cool. Number 11. Okay, number 11, the rise to run ratio of a roof of a house determines the steepness of the roof. The rise to run figure is 3 to 4. So as a rise of 3, run of 4. Determine the maximum height in the attic of the house when the house is 32 feet wide. Trying to determine the best way, I think, to do this problem. Because the best way to do this problem is actually not to treat it as a linear equation. You have two options when you do this problem. One is write a linear equation. God, just the writing on here is just so bad. It just looks awful. Okay, but that is actually not, I think, the easiest way to do this problem. The easiest way, I think, to do this problem is to use your ratios. So I would set this up as saying 3/4 is going to have the same ratio as what over 32. Right? And then solve that for x. The idea here is this has a rise of 3 and a run of 4. Oh, no, not 32. Not 32. Danger, 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 danger. 32 is the whole length. We only want to the halfway point. 16. We almost had it. That was fire on board there. And then solve this for x, cross multiply and divide. That's probably the easiest way, is to do this like it's a geometry problem where you solve it with ratios. If you did want to write it as a linear equation, then you would say, and here's how you would do it. I know most people are going to say, all right, I've stopped listening because that is not as easy. This is the slope, right? Rise is 3, and then run is 4. And then the point we know we can start with is, let's call this point where it starts as having a height of 0 and a width of 0, right? That'll be your x sub 1, y sub 1. And then once you write your equation with that, you can then plug in 16 into that equation for x and solve for y. But again, this, easier way to do it. I have one student in my geometry class who, for that survey, put for the prompt, the best teachers for me are teachers who Mrs. Ho. That's funny. Number 15, the challenge. Oh, yeah, okay, I'm not muted anymore. Why did I put that prompt? The challenge question. Okay, contractor purchases a backhoe for $84,400. The backhoe requires an average expenditure of $10 per hour for fuel and maintenance and $49 per hour for other owning and operating costs. Customers are charged $150 an hour for the backhoe use. Use the profit formula. Profit equals revenue minus cost to write an equation for the profit gain from T hours of use. Use your formula to find that break-even point. Number of hours backhoe must be used, gain profit to $0. All right, here's how you do it. P, let's try. Let's try. P equal R minus C. You might say, hey, Mr. Lake, I don't know what that is. And I don't know what that is. Or do you? What's the revenue? How much money we making?
$150 per hour.
So per, what do you want to use? Want to call this X or H or, oh, it says T. JK, you don't get to pick. T. R equal 150 T. What C you say? Let's use a different color for C. Let's use a different color for C. What's your cost? How much money am I losing on this backhoe? And don't forget that's a big cost right there.
84,400 minus 59T.
Okay, now he's a little thing. It's gonna be positive 59T. The reason why we're gonna write cost as positive is because we already put the negative right there. So we're gonna take care of that negative later. All right, and so then with my powers combined, that means the profit is 150T minus 59T minus 84,400. All right, equation is written. Equation is written. This is equal to P. Okay? And now that the equation is written, you need to find that break-even point, which means the profit is going to be 0, and then solve for T. And who said you're never going to use pre-calculus in your real life? When all of you have backhoe businesses 10, 20 years from now, you're going to be saying, thank goodness for Mr. Lake. Teach me how to calculate the profit on that backhoe. All right. Well, it's almost 9:30. So I have to say, really appreciate you all. It was a great class. You all asked great questions and participate really well. I appreciate that. Wednesday, remember, have WebAssign ready, have the calculator ready, and hopefully you'll have your homework done and turned in by then. And we're going to move a little bit quicker. All right, remember it's third hour next. Have a good rest of your day.